In this video, we're going to be solving real-life problems regarding hypothesis testing divided into 5 topics. First one is central limit theorem. 2 is one sample c-test. 3 is one sample t-test. 4 is c-test for proportion. 5 is c-test for 2 proportions. Now let's proceed to the first one, central limit theorem.
Step 1. Identify the mean. P is greater than 25. Step 2. Find the mean. The mean is 25 and the n is 5 and the mu is 20. Step 3. Solve for the z-score using the z-test formula. Z is equal to x minus mu over standard deviation over square root of n and substitute. X is 25 minus mu is 20 over standard deviation 10 and n square root of n is 5 and the answer is 1/12. Step 4. Find the probability using z-table. We have 0.1340. Convert it to percentage. 13.14%. Step 5. Illustrate. The shaded part is the probability. Problem number 2. The given is greater than 120. The x is 120, the n is 120, the mu is 100. And substitute. Z is equals to 120 minus 100 over 20 over square root of 20. The answer is 2.5 and look at the t-test and this is the answer 0.9938 and convert it to percentage 99.38 and this is the fraction.
So that's it for the central limit theorem. Next is one sample c-test.
Problem number 1 for z-test, our given are u is equals to 1.2, sample size is equals to 20, sample mean is 1.16, and standard deviation is 0.08. Step 1. State the null and alternative hypothesis. For this problem, the null hypothesis is mu equals to 1.2 and the alternative hypothesis is mu is not equal to 1.2. Step 2. Choose the alpha level. For this problem, the alpha level or significance level is given. Alpha is equals to 0.05 and this problem is detailed. Step 3. Critical value or find the critical value of t. Critical value is equals to positive and negative 1.960. For step 4, calculate the given problem. The formula we are going to use for this problem is z is equals to x bar minus mu is over standard deviation over square root of n. And then substitute the given to the formula. 1.16 minus 1.2 is all over 0.08 over square root of 20. The answer will be negative 2.24. So step 5, decide. This is where you are going to illustrate your problem. Since the answer is at the accepted area, and so we are going to reject HO. Step 6. Conclusion. Since we reject HO, we can say that there is sufficient evidence to support the claim mu is not equals to 1.2.
Problem number 2. Step 1. HO mu is equals to 100. HA mu is not equal to 100. Step 2. The standard deviation is 0.01 and we know it is 1/8. Step 3. The z is equal to 2.236. So step 4 we're going to compute, and this is the formula. Z is equal to x bar minus 1 over standard deviation over square root, and it will lead us to z is equal to 4. Step 5 we're going to decide, and the step 6 will be our conclusion. Since we reject HO, we can say that students in his school are above intelligent. So here's the given problem number 3. The mu is 100, the sample mean is 102.96, the sample size is 36, and the standard deviation is 15. Step 1, HO mu is equal to 100. HA mu is not equal to 100. Step 2, the alpha is 0.01 and we know it is detailed. Step 3, Z is equal to 2.576. Step 4, we're going to use this formula. So Z is equal to x bar minus 2 over standard deviation over square root f, and the answer will be 1.17. Step 5, we will decide. So here's the graph. And step 6, we will conclude. Since we do not reject HO, we can say that there is no sufficient evidence to conclude that the drug doesn't have significant effect. Thank you.
Third is one sample t-test.
First, let's list down the given. For the mu, or the average score of the population in general, it is equal to 70. The x-bar, or the average of the score in the sample, it is equal to 79.17. In this problem, 62 plus 92 plus 75 plus 68 plus 83 plus 95 is equal to 475 divided by 6 and is equal to 79.17. Next is the S, or the sample standard deviation, is equal to 13.17. We get this through the solution square root of summation of x minus x bar squared over n minus 1. Next is the sample size, which is 6, and the level of significance, which is 0.10.
For the step 1, we will be formulating the hypothesis. In the problem, a keyword above is stated, which falls under alternative hypothesis, or HA greater than, which will be mu is greater than 70. And for the null hypothesis, or HO, we will just put the opposite, which will be mu is less than or equal to 70. For the step 2, we will put the level of significance, which is given in the problem, with the value of 0.10, the degrees of freedom with the formula n minus 1. In the problem, n is 6 minus 1, so degrees of freedom will be equal to 5, and the one-tailed test, which is because of the keyword t value, will be 1.476 relating to the t table.
Step 4. For this step, we will be solving for the C value with the formula x bar minus mu over sample standard deviation over square root of n. Substituting with the given in the problem, 79.17 minus 70 over 13.17 over square root of 6, which will give us 1.71. For the next step, step 5, we will be deciding on which to approve or to reject in the null or alternative hypothesis using the graph. With the given critical C value of 1.476 in the shaded area or the rejection region, which will be to the right of the distribution because the problem tells us it's above 70, and the C value of 1.71, we can say that since we reject the HO and accept the HA, we can conclude that the mean of the score is above 70. For the step 2, the level of significance is equal to 0.05, degrees of freedom is equal to 24, and the two-tailed test. Step 3, critical C value is equal to positive negative 2.064 because we use the two-tailed test. Next is the step 4, the Z value 4.6 minus 4 over 0.22 over square root of 25, which will give us 13.64. For the step 5, we will be using a graph to decide which hypothesis to accept or to reject. Given the critical C value of positive negative 2.064, the shaded region represents the rejection reason. We have the C value of 13.64. Given that this distribution approaches positive infinity, we can conclude that 13.64 is somewhere at this point, which then falls under the rejection region. So we can have a conclusion in relation to the problem. Since we reject HO or null hypothesis, we can conclude that there is a significant difference in the amount of latte served at the new branch in Manila and the original tech. Last problem, problem number 6. Given mu is equal to 69,873. X bar 79,180 pesos. Sample standard deviation 40,985 pesos. N or the sample size is equal to 12 and the level of significance is equal to 0.05. Step 1, hypothesis. For the null hypothesis, we have mu is equal to 69,873 pesos. And for the alternative hypothesis, we have mu is not equal to 69,873 pesos. Step 2, level of significance is equal to 0.05, degrees of freedom is equal to 11, and the type of test is two-tailed test. For the step 3, the critical C value is equal to positive negative 2.01. For the step 4, the Z value is equal to 79,180 minus 69,873 divided by 14,985 over square root of 12, which gives us 2.50.
There you go. Go!
Step 5, we will use the graph to decide which hypothesis to accept or to reject. Given the critical C value of positive negative 2.201, the shaded region, which again represents the rejection region, the C value 2.15, which falls in the non-rejection region or MRR, which gives us to accept the HO and reject the HA. For the step 6, the conclusion, since we fail to reject HO because the C value falls in the non-rejection region, we can say that there is no enough evidence for the researchers to conclude that there is a significant difference in the salary 6 years ago.
Next is C-test or proportion.
Problem number 1 for Z-test or proportion. Given proportion is equal to 90% or 0.90, P hat is equals to 82 over 100 is equals to 0.8. Q 1 minus 0.9 is equals to 0.10. N is equals to 100 and X is equals to 82. Step 1. State the null and alternative hypothesis. HO proportion is equals to 90. HA proportion is not equal to 90. Step 2. Choose the alpha level of significance. The alpha level of significance is equals to 0.05, and for this problem, we use 2 head. Step 3. Find the critical value of Z. Z is equals to positive negative 1.960. Step 4. Calculate the given problem. Z is equals to P hat minus E over square root of PQ over N is equals to 0.82 minus 0.90 over square root of 0.90 times 0.10 over 100. And Z is equals to negative 2.67. Step 5. Decide. Since our final answer is negative 2.67 and it is in the rejection region, we will reject HO. Step 6. Conclusion. Since we rejected HO, we conclude that there is enough evidence to support the claim proportion is not equal to 90.
Problem number 2. These are the given. Probability is 45% or 0.45. N is 125. X is 69. P hat is 69 over 125 equals 0.65. Q is 1 minus 0.45 equals 0.55. Step 1. HO is P equals 45%. HA is P is not equal to 45%. Step 2. Alpha is 0.02 is two-tailed. Step 3. Critical value is positive negative 2.326. Step number 4. P hat substitute to 0.55 minus probability 0.45 over square root. P substitute to 0.45 times Q substitute to 0.55 over sample size 125 equals 2.247. Step 5. This is the graph that shows HO is accepted and HA is rejected. Step 6. Since we do not reject HO, we can conclude that 45% of the gamers own their PC.
Problem number 3. Given. Proportion is equals to 4% or 0.04. P hat is equals to 25 divided by 500 is equals to 0.05. Q is equals to 1 minus proportion or 1 minus 0.04 is equals to 0.96. X is equals to 25 and N is equals to 500. Step 1. HO P is equals to 4%. HA P is not equal to 4%. Step 2. Level of significance is equals to 0.05 and the problem is 2 10. Step 2. Z is equals to positive negative 1.960. Step 4. This is the Z formula and is equal to 0.05 minus 0.04 over square root of 0.04 times 0.96 over 500. And the answer will be Z is equals to 1.14. Step 5. Since the answer is 1.14, our HO will be accepted. Step 6. Since we accept HO, there is not enough evidence to support the claim P is not equals to 4%.
Lastly, see test for two proportions.
problem in z-test for two proportions, here are the given. So sample size number 1 is 300 and sample mean is 240. So sample mean number 2 is 105 and the sample size is 160. So the general formula for proportion is x over n. So to solve for proportion number 1, it's equal to 240k over 300. And for proportion number 2 is 105 over 165. So proportion number 1 is equal to 0.81 and proportion number 2 is 0.61. So to solve for Q1 is 1 minus Q1. So 1 minus 0.81 is 0.92 and Q2 is equal to 1 minus P2 equals to 1 minus 0.64 is equal to 0.36. So for step 1, set up the hypothesis. So for null hypothesis, proportion number 1 is less than or equal to proportion number 2. So for the alternative hypothesis, proportion number 1 is greater than proportion number 2. So in step 2, set the level of significance. So the level of significance is 0.05 and the problem is 1/3. So for step 3, determine the critical value of z. So find 0.05 on your t table will result to 1.645. So for step 4, compute the test value. So z is equals to proportion number 1 minus p2 over square root of p1 times q1 over n1 plus p2 times q2 over n2. So then substitute the given. So answer is 5.0. So step 5, illustrate. This is also called the decision rule. So shade the part from the z critical value 1.645. Then locate the z-test value 5.05. Since 5.05 is located at the shaded part, where it also called the rejection region, so we have to reject HO. So for step 6, the conclusion. Since we reject HO, there is enough evidence to support the claim. So the given for problem number 2, x1 is equals to 12, n1 is equals to 46, x2 is 9, n2 is 49. Question number 1 is 0.96 and question number 2 is 0.18. So Q1 is equals to 0.74, Q2 is equals to 0.8. So for step number 1, state the hypothesis. So for null hypothesis, P1 is less than or equal to P2. For alternative hypothesis is P1 is greater than P2. So step number 2, the level of significance is 0.10 and the problem is 1/10. So step 3, the z critical value of 0.10 is 1.282. So step 4, compute for the z value. So the z value is 0.95. So for step 5, illustrate. So we located the z-test value 0.94 and it is placed in non-rejection region. So do not reject HO. So conclusion, since we accepted HO, there is not enough evidence to support the teacher's claim. So for problem number 3, here are the given. So x1 is 187, n1 is 336, x2 is 134, n2 is 245. Then p1 is 0.57, p2 is 0.55, q1 is 0.43, and q2 is 0.45. So for setting up the hypothesis, so null hypothesis is p1 is equals to p2. In alternative hypothesis, p1 is not equal to p2. So, step 2, the level of significance is 0.05 and the problem is two-tailed. Step 3 is Z critical value of 0.05 is positive negative 1.96. So, for step 4, compute for the Z value and the answer is 0.40. So, step 5, illustrate. Since the zeta's value is 0.48 and it is not located in the rejection region, we do not reject HO. So for the conclusion, since we do not reject HO, we can conclude that there is no enough evidence to support the claim.
That's all for today's video. Hope you all learned something. This is Congquering Stats TV. Don't forget to give this video a thumbs up and watch out for more. Bye.